All right. Hey, everybody. Welcome to episode 7 of ChatLoopBackOff. Today is April 4th. Wow. It's April already. It's pretty crazy. My name is Jeremy Rickard. I'll be the host today. I'm happy to be back to learn some more things about the cloud native landscape with you. If you haven't tuned in before, this is a program that dives into the realms of the cloud native landscape, takes a look at projects, and kind of walks through the learning process of the host to better understand some of those projects. It's been a few weeks since we've done one of these, and I'm pretty excited to be back. If we haven't met before, it's a pleasure to meet you. My name is Jeremy again. I am a chair for SIG release in Kubernetes. I'm also on the Code of Conduct Committee, so you may have seen me in a few other places. Uh, it's spring here again. Kind of crazy. I was thinking about the last episode we did of this show that I got to host, and we were expecting a blizzard in Colorado, and it delivered. My kids had no school, and then they were on break for a little bit. And now we've totally pivoted, and it's like 65 Fahrenheit here. Super, super nice. Can't believe how quickly time is passing. If you've never turned into this stream before, welcome again. This is a live stream that's a similar kind of a sibling show to ClatLoopBackOff, which you may have seen at KubeCon. In that, it's an event kind of competition style where two competitors or two people from the community are pitted together to solve some sort of technical challenge that's been decided and not told to them ahead of time. So it's kind of a laid back maybe experience for folks, definitely for the audience, and it's meant to be a good time where hopefully everybody can learn a little bit together. I was super bummed to miss the instance in Paris. I got to do it in Chicago, and it was super fun. I hear there were really great competitors, and the challenges were really cool. So hopefully I'll get a chance to do it again in Salt Lake City coming up in a few months. That'll be really great. This stream is a little different than that. It's, again, more focused on the host kind of going through a topic and understanding it a little bit better, learning about some project in the cloud native ecosystem. I haven't done any in-depth research on this project before. I think that's a key thing to understand as we dive into this. I'm going to come into this pretty fresh without really having much background on the project. I know generally what it does, but I haven't looked at how to install it, and I don't have it on my machine today. So as we go through that, if you have questions, feel free to ask them in the chat, and I'll try to keep up with some of those. If you see me get stuck with something, definitely chime in and offer your feedback. If you've used the project in the past, that would be really great to have some sharing of knowledge between us and the audience. Today we're going to learn about Buildpacks, which is a CNCF incubating project, and the purpose of the project is really to think about how we build cloud native applications. Generally, you're going to take your application, you're going to result in, the result will be a couple of a container or multiple containers that package your application up and make them ready to go without having to use Docker directly. I think that's the key point of it, from what I understand. During this live stream, again, if you have questions, feel free to drop them in chat. If you have suggestions that can help me get unblocked, totally speak up. That being said, this is an official live stream of the CNCF, and it is subject to the CNCF Code of Conduct. So please don't add anything to the chat that would violate the Code of Conduct. And please really just respect your fellow participants and me, the presenter. This video will be put on the YouTube afterwards, so folks that aren't able to attend today will be able to join us asynchronously. Before we get going, I thought we could highlight some news from the cloud native world. It's been a few weeks, so we have a few topics to look at. I'm going to go ahead and share my screen, and we can take a look at a couple of different items. We're going to share this one, and should be good. Okay, cool. So first up, this was announced during KubeCon. I thought it was pretty cool. It's a project called SpinCube, and it's a way for you to deploy WebAssembly modules or workloads into your existing Kubernetes clusters. And I think that's a pretty cool way to be able to get started, learning this kind of new paradigm of how we're going to package applications and workloads outside of traditional Docker containers. There've been a few other ways of doing some, non-traditional workloads inside of Kubernetes, but I think this one's seems like a pretty cool way. I've seen a lot of chatter about this. I'm really excited to take a look at this at myself some point in the future. And I did see that the Fermion folks plan to donate this to the CNCF and have applied or will be applying to make this a incubating project, a sandbox project within the CNCF. So if that gets accepted, I think this would be a really cool project to take a look at, really relevant to a lot of changes that are happening in the ecosystem at some point on a later stream. So hopefully, knock on wood, that happens. Another interesting thing that happened during KubeCon, so some folks may have missed it, but at this point, it's been pretty well out there, that Redis has adopted a new dual source license. Caused a lot of concerns and a lot of frustrations to be voiced on social media and other places. And it seems like an outcome of that is that there's been a fork of this project called Valky that is also being donated to the Linux Foundation in order to continue developing what was Redis 7.24 under a license that is more amenable to open source consumption by everybody. So this will be an interesting one to kind of take a look at going forward. Looks like it's got a pretty big backing from AWS and Google, Oracle, Ericsson, Snap, some end users. It'll be really interesting to see how this project kind of unfolds going forward. All right. Last time, if you were here again, I mentioned Kubernetes 130 is coming out really soon, and I'm going to mention it again because we're so close now. We are just about 2 weeks away from Kubernetes 120 being released, or sorry, 130 being released. You can see the release date for that is going to be Wednesday, 17th of April. I think this is super cool. I was the release lead for Kubernetes 120, so we're now 10 releases away from Kubernetes 120 once this comes out, and it's super exciting to see all the changes that go into all of these releases and get an opportunity to take a look at all the things that are coming. This time around, there's been a sneak peek. I'm going to just share this link, and I'm going to share all of these as notes in the show notes later on, so folks can take a look at them if they want. But I think this is really cool. It's got a couple of big changes that are either graduating or will be new things to take a look at inside of Kubernetes 130. A couple of cool things that really stuck out to me were Cell, the common expression language for mission control. That's going to be a feature that you'll be able to rely on inside of 130 going forward. That's pretty cool. I think the swap support is also one that's been interesting to see kind of evolve over time. This is still going to be in beta. It'll be available for folks to try out, but it seems like a pretty interesting change. There's a blog post you can take a look at for that one. I'm not sure if there's one for the cell policies yet, but you can check out the KEPs here. KEPs are Kubernetes enhancement proposals. They're pretty cool. You can click through to them and you can see all of the information about what's going to go on inside of that change. It's really cool. You can see all the work that's gone into it. And this one definitely you can see has had a lot of PRs and a lot of work that's gone into it. So it'll be really cool to see this graduate to a stable feature in 130. Speaking of those releases, I think a lot of people probably don't try out the earlier releases. If you're not aware, Kubernetes does alpha releases, it does beta releases, it does our release candidate releases. So you can kind of see some of these throughout the timeline. There was an alpha 3 release back in February, a beta release in March. The very first alpha release was back in January. So you could have tried out some of these things over time. And I think that's a really good way to give back to the project. If you're able to, you can, be pretty assured that these release candidates are pretty close to where you're going to want to be able to try them out. This is the point at which the branches get created, and we are really restrictive on what things are going to get merged into the project at that point. So you can have some pretty good assurances that those things will be ready to go. And we do build containers and packages for all of those things, so they're pretty readily available to try out. And DIMS, if you're not familiar with DIMS, a great person to follow on different social media platforms. He put out a call for folks to test out the release candidates back when we did the RC0 a few weeks ago, March 28th. This thread, I'm not logged into what used to be called Twitter, so I can't actually access the whole thread, but there was a bunch of good information in this tweet, the replies to this tweet, that shows you how you could take advantage of some of these releases and try them out before the .0 comes out in 2 weeks. So you're able to open bugs or provide feedback and get some of those changes into the .0 release before it comes out for Kubernetes. I think we've seen a lot of work go into making these releases more and more stable over time and trying to eliminate any bugs that go into them. But any extra help that folks can have by taking a look at some of these things and putting extra eyes on things is super useful in making some of those releases a little bit more stable. And kind of on that topic, the last little piece of information that I wanted to share, news-wise, is that Jordan Liggett has been doing, Liggett, if you've seen him on GitHub, has been doing a bunch of analysis on regressions per minor releases. This is some work we've been doing as part of the LTS working group, another thing that I've been working on in Kubernetes, kind of looking at how stable are these releases. When you're going to go from a minor or 125 to 126, for example, what kind of issues can you expect in terms of regressions? What can you see from patch release to patch release? So maybe going from 128.3 to 128.4, how many regressions are there? And I think there's a lot of detail inside of this. Again, we'll share the link as part of the show notes. You have to be part of the Kubernetes dev mailing list to access this, but that's a pretty easy thing to get. There's a lot of detail that goes into this and links to a whole bunch of different information if you want to kind of drill down into things. But I think some really cool information that kind of came out of this is that we are looking at probably the least number of regressions that have come in most recent releases. So kind of common concern that we've heard from folks in the past is that there are a lot of regressions, and upgrading from patch release to patch release is something that's not really safe or stable to do. And that's actually not true based on the data that we're seeing as part of this regression analysis. So I think it's really cool data, lots of cool stuff to take a look at. Would encourage folks to take a look through that if they have the interest. Okay, so with all of that out of the way, we are going to dive into cloud native build packs. So I'm going to close those other tabs to get them out of the way for now. And I'm going to jump back over to this other screen so that I can take a look at any comments or questions that come in. But without further ado, let's dive into cloud native build packs. And I think you can see a bunch of really cool information right out of the box about, what's the use case or what's the value prop for using something like Buildpacks. We see compliance. I think that's something that a lot of people in the enterprise world are interested in. Performing upgrades with minimal effort and intervention. That sounds like something that anybody would be interested in. A balance between app devs and operators. I think that line kind of blurs from place to place, but it's a cool one to keep in mind. But really, I think the mission statement here seems to be transforming your application source code into images that can run on any cloud without having to necessarily use, lower level Docker technologies directly. So let's go through this documentation, see if we can get to a point where there's some good quick start or how to, and then we'll dive in and try some of this out. So what does Cloud Native Buildpacks do? Transforms your application source code into container images. We said that before. You can concentrate the knowledge of the container build best practices within a specialized team instead of having app developers across the organization individually maintain their own Docker files. That's a pretty attractive kind of thing to do when you get to a really, really large organization. In my day job today, we're doing a bunch of things to try to standardize folks and really apply security best practices across things. And it's difficult because it's kind of like the Wild West, and there are so many different ways, so many different teams have been doing different things. Okay, so this makes it easier to know what's inside the application images, enforce security, compliance requirements, and perform upgrades. Yeah, that sounds super cool. Buildpacks were first conceived by Heroku in 2011. That's a long time ago. Since then, they've been adopted by Cloud Foundry and platforms as a service like Google App Engine, GitLab, Knative, Deis, Doku, and Dry. I don't know the last two, but I'm pretty familiar with these other ones. And I've definitely seen them being used inside of Knative. Cloud Native Buildpacks were initiated by Pivotal and Heroku in January of 2018 and joined the CNCF in October of 2018. So they've been in the CNCF for quite a while. We're in 2024 now, so that's pretty far away. The project aims to unify the Buildpack ecosystems with platform to build contracts that's well-defined and incorporates learnings from maintaining production-grade Buildpacks for years at both Pivotal and Heroku. Cloud Native Buildpacks embrace. Yeah, sure, I can increase the font size for sure. Let me know if that's any better. Hello. Okay, I'm going to assume that that's big enough, and we'll go from there. Left off right here. So Cloud Native Buildpacks embrace modern container standards such as the OCI image format. That's pretty cool, and takes advantage of the latest capabilities of these standards such as cross repository blob modding and image layer rebasing on Docker v2 APIs. That seems pretty cool. Looks like we're going to jump right into a tutorial now, and we're going to start by probably installing the pack CLI. So I'm going to jump into the tutorial and we'll kind of work from there. As we go, I'll try to maybe make some callbacks to, or if they don't show it, callbacks to like how you might do this with Docker files or with other tools in the space, because there's actually a bunch of tools in the space that are doing, you know, code to image kind of builds. Okay, so in this tutorial, we're going to use Pack. Pack uses Docker or a Docker compatible daemon. So I do have Docker already. It looks like you can use it with Podman. I do not have Podman installed, so we're going to use Docker. I don't have Pack installed though, so we're going to go ahead and install Pack. And I'm going to use Homebrew to do this, because I'm on a Mac, and that seems like a good thing to do. All right. Okay, I'm going to start out here. We're going to brew install Buildpacks tap pack. And while that's running, jump back over here. Cool. They have auto completion for ZSH. That'll work for me. We'll do some of that when we get there. It looks like you're able to run this in a container, which is pretty cool. So without having to install anything, you can just run it that way. You can manually install it. You can do everyone's favorite thing of curling and then passing it to a shell. That seems like another great thing to do. Looks like there are Linux and Windows installation steps for this. So looks like you're pretty much covered no matter what dev OS you're running on your local machine. So that's pretty cool. Okay, let's see how this is going. Still installing a couple things. Okay, I'm going to jump back to that previous page. Actually, let's see if there's anything we need to do in here. I think this is the only thing that I really care about. I'm going to add that to my ZSHRC file. I'll put that there. Oh, actually, it's not installed yet. Okay, it is installed now, so I should be able to do this. All right, so while that's running, let's go back to the tutorial. Okay, Buildpack Basecamp. Before we set out, you need to know the basics of Buildpacks and how they work. So what is a Buildpack? A Buildpack is something you've probably used without knowing it, as they're currently being used in many cloud platforms. That said, while Buildpacks are often a behind-the-scene detail, they're at the heart of transforming your source code into a runnable app. Okay, auto detection sounds cool. This enables them to be transparent. Okay. So it's going to look at your source code to try to determine what kind of base image you're going to look for, what things need to go into the application, and how to build it probably. So that's pretty cool. What is a builder? It's an image that contains all the components necessary to execute your build. A builder image is created by taking a build image and adding a lifecycle, build packs, and files that configure the aspects of the build, including the build pack detection order and the locations of the images. Okay, so they've got a tutorial we can work through here. Looks like it's a simple Java app. That's what I had in mind too. So we'll just use theirs instead of starting from scratch. That seems like a pretty good thing to do. So I'm going to go back over to this terminal window, clear, and then we're going to clone that. All right. So we've got our samples directory here now. I'm going to bring up a VS Code window just in case we need that. Cool. Got a bunch of stuff in here. We have a Docker file for Gitpod, but not a regular Docker file. So I would expect that because of we're using Buildpacks instead of straight up Docker files. Looks like we've got a couple different directories in here with some application stuff and some base images. A couple different stacks. So if you want to customize it, looks like you can do different base images. That's cool. Builders. Yep, a sample of builders that use the base images in this repo. That's cool. And Buildpacks. Okay, we've got a whole bunch of different ones. This repo is laid out pretty nicely. So shout out to the Buildpacks people for including nice directory level README files. That's pretty cool. Okay, so we've got that clone. Let's go back to the tutorial. So we want to go into the Java apps subdirectory. So samples, apps, Java, Maven, and then we want to build the app using Buildpack. Okay, so let's give that a shot. So we're going to go to this directory. Oh, I'm already in samples. So I'm going to do cd apps Java Maven. And then, oops, we want to run the pack CLI. Before we do that, let's just run the pack CLI without anything. See what we're working with here. So we've got that in CLI installed. It's a CLI for building apps using cloud native Buildpacks. Oh, you're not seeing my terminal. Okay, hold on. Sorry about that. I was only sharing a window. Sorry, that was my bad. Thank you for calling that out. Is the terminal coming through now? I think I see it in the preview window. So I think we're good now. Okay, cool. So just yeah, thank you for confirming. So all I've done so far, since we couldn't see the terminal before, is I've cloned this repo with the git clone command, and then I've changed into this samples apps Java Maven directory. So inside of here, we've got a basic Java application that uses Maven to do the builds. So the pom.xml has a bunch of Java specific things about how to build, which plugins it's going to use. This is a Spring Boot application, so it's going to use a bunch of those things. Under source, we've got our Java directory, resources, and just some properties files. I think the one thing to notice inside of this is that we don't have a Docker file, so there's definitely none of that. We're going to use Buildpacks to do that, so that'll be really cool. The last thing I was showing before we noticed that the terminal wasn't there was that the pack CLI is installed. It's got a whole bunch of different commands. We'll see how many of these we get through. I think the first one we're going to look at is build. So generating an app from source code. That's probably the thing that folks are going to be most immediately interested in. So I think we're going to dive into that one. If we go back to the docs for a second, we're going to run pack build, which is going to be that command right there. So let's do pack build and see what it gives us as options. You can specify the builder you want to use. You can specify Buildpacks, the registry. So there's a lot of customization that you can do inside of this. I think we're going to start off with a little less customization and go with just the recommended basic thing here. Hello in Paris. Nice to see you. Okay, so we're going to use the pack command. We're going to do pack build my app, and I think we're going to specify the builder here, which is going to be the simple builder Jammy. So let's run this. And there's a note below. If this is your first time running pack build, you'll notice the build might take longer than usual. It's going to cache things for us. So this is the first time I've run this, so this is going to probably take a little bit of time. So we'll do some more exploring while that's running. But let's give it a shot and see what happens. Okay, so that looks like a Docker build happening behind the scenes. Oh, could not get decompression stream fork X. That looks like it is a Mac M1 problem. Let's go back to this and see if there's any information that might help us debug this. If anybody has used Buildpacks on an M1 Mac and has run into a similar issue, please feel free to share it in the chat, and we can get us kind of unblocked a little bit. I would guess that because this is not an Intel processor, it's not an x86. That's probably what's coming into the issue here. I wonder if, so we're going to use this tool called Oras, and we're going to look inside of this repo and see if there's anything that is ARM specific that might help us out. Okay, so we've got an Alpine, Bionic, Jammy, Nano server. There has to be a command that helps you list the available builders you may use. Yeah, let's check that. I think there was a pack builders command here. Okay, we've got some suggested ones from Paketo, from Heroku, and from Google. Let's try this as a different builder. Actually, let's try the Google one first. It's an older version of Ubuntu, but let's see if that works for us. This is a pretty cool thing. I definitely think that if I was running this in my environment, I would probably want to host those Buildpacks or those builders in a repo that I control, a registry that I controlled, just for more supply chain security assurances. So it's cool that you can specify different ones and override that. Let's keep our fingers crossed and see if this one builds for us. Nope. Let's take a look at the manifest for that. Let's see if it has a. Yeah, this is an AMD 64 image, I would guess, not for ARM. Okay, let's try the Paketo one and see. Okay, we'll just try it with this one and see if that works. Yeah, it doesn't look like these are multi-arch images, so that may be a problem for my M1 Mac. Yeah, it's just a regular manifest. Okay, so we'll give that a try, but I think we're going to run into the same problem. So might need to go to the docs again and try to find some more info on how we use it with a non-AMD 64 machine. First thing I would probably do for that is to find their GitHub repo. All right. Well, it looks like there is an issue on an M2 Mac with Podman, not using Podman. So hopefully not that. Okay. Well, that probably is not my issue because we're not getting that far. Okay. Let's take a look at the pack build command and see if there's anything that allows us to specify the format we want to use. It's not a multi-arch image, so I don't think that'll matter, but all right, let's try Google search. And our error is I wonder if I need to enable Rosetta again. No, it doesn't seem like it. Could be a broken. Let's try just running one of these images and see what happens. And what version of Docker do I have? 427.1. Okay. Is it related with your current build kit builder instance? Docker buildx ls to see which builder I'm using. That's good. Good idea. I am using the default one from Docker. Let's just make another one and switch to a new build kit and see if that does anything. While that's going, this seems like my Mac is not doing correct things. I would not expect this error to come through. Just trying to create a build kit instance. Yeah, it's possible to increase the terminal size. There we go. Let's try that. Okay. Let's see if I can just run just like regular. Maybe my Docker needs to be restarted. Oh, I spelled Nginx wrong. That's why. Yeah, something's wrong with my. Let me restart Docker. Sorry for the technical difficulties. Let's try to use the desktop Linux. Use, not user. If anybody has any other suggestions, feel free to throw them into the chat. Let's verify if I can make another kind cluster. I have one running, so should be okay, but let's give it a shot. Okay, while it's running, I'm going to make sure that yeah, that has a ARM64 Linux instance. I should have been able to run that. Yeah, I have not seen that error before either, which is unfortunate. But it is failing to create a kind cluster now too, which is like all of the binary formats are incorrect. That is super weird. Let's see if anybody has solved this for us on the internet already. I think this is the same one we looked at just a second ago. And this is a mini cube issue. Yeah. That's super weird. I can't do anything with Docker here. Let me force quit it and run it again. Tom in the chat says, this is a life of running clusters on M1. Even if it's not the root cause, it's always in the back of your head. That is true. I've had pretty good luck with Docker on this M1 so far, but not now, I guess. Now it's not being so nice. And it doesn't seem like it's actually starting. My Mac is not being very happy today. Yes, Docker is running according to this, but I don't think it is running correctly. Yeah, it's not showing up here. Super, super strange. Oh, well, we're running out of time. So let's just take a look at some more of the documentation for Buildpacks since I'm not able to get it to run on my Mac. Definitely doesn't seem like it's a problem with Buildpacks. Definitely seems like it's a problem with Jeremy's installation of Docker for some reason, or Jeremy's computer, which is unfortunate. I apologize for that. Okay, so what this will end up doing is building us a new container. We see here when we do a Docker run here, it's going to use this as the tag. So let's go take a look at the commit, the pack command for a second. Look at the help screen. So when you run this, oops, test image is going to be, I think, the name of the image you want to build. It does look like you can specify other tags. So essentially, when this is running, it's going to generate something like my app latest. You're not specifying a tag right here. So it does look like you can override that here. You can specify additional tags to push the output image to. I'm curious if it does push directly to, oops, if it pushes directly to your registry by default. No, I think it goes to the daemon by default. You have to use this publish flag to make it go to the actual the registry. Okay. Ah, that's cool. SBOM output dir. It'll generate an SBOM for you. Omitting this flag will yield no SBOM content. So if you want to generate an SBOM for that, that's a really cool feature built into this, that it'll generate a software bill of materials for you by default. if you provide this output directory. That's a really nice feature that's built into that we didn't get a chance to take a look at. Okay, back to the docs. Oh, really cool. Windows builds are something that you can support. What's that look like? For Linux containers, that's pretty neat. Looks like it's pretty similar. We are gonna run pack build and really just specify a different builder to go along with that. That's pretty cool. Building in custom environments. Build for the ARM architecture. So this is useful information. My Mac should, with Rosetta running, let me run AMD 64 images and build AMD 64 images. Like I've done that before, before today. But it's pretty cool that they've got documentation for building ARM specific images here as well. I will try this out later on and make sure that I can get that to work. I think the other interesting one here is using Podman. I think we're starting to see a lot of folks migrate away from Docker to other alternatives. Podman is one that people seem to be really into. Lima is another one that's kind of interesting. It would be interesting to see how that would work with this. I wonder if I install. I probably don't have time to install Podman to do this for this live stream, but there is really good documentation here. It looks like for switching over to use Podman instead of using Docker directly. That's pretty cool. I want to understand the build outputs. Let's take a look at the SBOM piece is interesting to me. So let's take a look at that. So they will generate SIFT or Cyclone DX or SPDX. That's cool. The SBOM can also be downloaded, it looks like, after build time. So you can specify that command with pack build, but also you can use pack SBOM later on to do that. That's great. Lots of really good information here. So definitely I would recommend checking this out on your own. Make sure you got a working Docker instance, since it's not being too happy for me today. But there's a bunch of really useful information here. Starting with the tutorial, I think is useful. I think this concepts page has a lot of really specific information that will be useful as you're kind of walking through this journey. Builders are OCI images that contain a combination of build packs and build time base images. What happens during a build? Let's read that one real quick. Well, we've got a few minutes left. So build is the process of executing one or more build packs against an application source code to produce a runnable OCI image. So the builder image has one or more build packs inside of it, and it takes your app and then produces your app image. So these layers can come from multiple build packs, it looks like, so you can specify multiple of those. The runtime image, which is going to be that base image, and then your application itself is there. Rebase, that's kind of cool. So Rebase allows you to rapidly update an image when its runtime base image is changed. So if you're maybe basing on Ubuntu 2204 and a new version comes out, it looks like that allows you to do that pretty easily. And there's a pack rebase command that does that. So let's see what that looks like. Yeah, that's pretty cool. It'll perform a rebase operation. You can skip validating, probably not a good idea, but you can actually have it published directly for you afterwards. That's a pretty great feature as well. All right, well, I'm going to end it here since I'm not able to get this to run on my my local machine. I apologize for the inconvenience. Maybe we can do round 2 of this as another live stream after we get my technical issues figured out. Thanks for joining me today. Again, apologies for the technical difficulties. I hope to see you